Yep, so for those of you that aren't on mute, if you could please mute your lines just so we have no specific interruptions, that would be helpful. Wanted to thank everyone for taking some time to join us this afternoon. We really appreciate it. My name's Dan Petito. I'm an inside account manager here with Design Point Solutions, and I'm also joined by my colleague, Matt Devine. Matt is a senior application engineer here with Design Point Solutions, and just going to be touching on some things for individuals and companies that are basically thinking about adding 3D CAD into their design flow. Whether they're using 2D AutoCAD or 2D tools today, I'm going to run through some specifics within SOLIDWORKS 3D CAD software, some core capabilities that basically you can't do with 2D CAD. So we hope you find it valuable. And we're just basically going to take some time to jump right in. As far as questions and things like that, we're asking if you can please obviously save them for the end of the presentation. We'll do our best to get to them. Again, if you have any, just please insert them into the question box. And once we're at the end of the webinar, Matt and I will get as much answered as we possibly can. So again, appreciate you joining us. And this is just kind of a quick snapshot as far as today's agenda is concerned. Basically just going over 4 specific things you can't do in 2D CAD. The first of which being data reuse, reusing existing 2D CAD data into 3D. Also automatic updates to all drawing views. Finding, identifying interferences before drawings get to the shop. And lastly, creating exploded assembly drawings and bills of materials in minutes. So we're going to go ahead and get started here. Hey, Matt, know you're there. 2D data reuse. So look, I already have all this work, right? I already did all this work. I don't want to redo it again. I have all this 2D DWG files. It would be pretty awesome if I can import that into SOLIDWORKS. Is that something I'm able to do?
Sure, Dan, and that's a great question. I can understand your concern there because you did put a lot of time into some of these drawings that you've been working with in the past. So let me go ahead and show you how we can actually utilize and reuse some of that 2D data so you're not really using or losing a lot of that work that you've already done. The first thing I'm going to do over here is switch to DraftSite. So DraftSite is a 2D CAD tool that you can see, and this looks like this was your DWG file, Dan, that you saved and started working on earlier. So this file does come straight from DraftSite. You can see I can move the files around. I can work with it in this tool. But what I really want to do is bring this into SOLIDWORKS and see how we can make this into a true 3D part. So I'm simply going to shut this file down and then open up my SOLIDWORKS interface. And from here, within the SOLIDWORKS interface, it's built off the Windows platform. So you're going to have all the familiar menus at the top of the menu, or at the top of the menu bar. A lot of the standard icons like open and files like that. So what I'm going to do is actually take a look at that clamp.dxf file. And you can see I can identify that file right here in the open dialog. So I can open a DXF straight within SOLIDWORKS. And this is going to help you out, Dan, because now you don't have to try to translate that data into another file type to bring that in and start working with it. So what I'm going to start with here is just importing the new part as a 2D sketch into my current SOLIDWORKS document. And we can go through some of these settings here. I'm going to make sure it's in millimeter settings. We can import any of the dimensions that you've already established, as well as turning on and off specific layers. So for instance, your title blocks in the background there, we don't really need that, so I can turn that layer off, as well as any of those center lines and center marks. So we don't really need those in the 3D model. So we can just turn off those layers if you use them so that we're not running into those items being in our drawing. After setting up some of our settings here, we simply choose Finish. And what that's going to go ahead and do is import that straight into a 3D sketch for us. So within the SOLIDWORKS interface, you can see that this is actually all 2-dimensional right now. If I grab the part and I rotate it around, you'll see this is located in space as just more of a flat type of sketch. So what I want to do now is I want to use this 2D to 3D toolbar that pops up for me to create a 3-dimensional part. In order to do that, I'm simply going to take some of these views that you have already established for us, Dan, and I'm going to say that this view here should be the front view. So these tools are very simple to use in order to convert your views into SOLIDWORKS views. So as I highlighted the top view here, now I'm going to choose the option to add that to the top sketch, and you'll see that sketch actually rotate normal to. So now as I start to rotate the part around in 3D space, you can see it actually reoriented that part of the sketch. I'm also going to grab this area here, and I know that that should be the right-hand view. So I'm going to add that to the right sketch. And again, just like the first version, that one rotated around to the side, so now I'm starting to get more of a 3D view. Now actually, this isometric view doesn't really need to be there, so I'm just going to highlight that and delete it. And then I can actually start working on these sketches a little bit more. So in the 2D environment, those sketches were each spaced out from each other a little bit, so you'll notice a couple of the gaps here and they don't exactly line up. But that's okay, because our 2D to 3D tools inside of SOLIDWORKS actually anticipate that happening, and they give us this nice aligned sketch tool. So what I can do here is simply select a few of these items and align those to each other. And what that's going to do is bring all of my shapes together so that I start to get one cohesive piece. I'm going to do the same thing with the top sketch here to make sure that that gets aligned up with the right-hand side sketch and the front sketch. And then I'm simply going to bring these two portions up to meet that top view. So you can see it's really quick to bring in your 2D data into SOLIDWORKS and actually get these sketches that are laid out in a three-dimensional view. So what I'm going to do with this part now is utilize more of those 2D to 3D tools. The one here is called Convert to Extrusion. So I can simply select this area of the sketch, and I can convert that to my 3D extrusion. What's great with this function is because I already have the sketches, I can use powerful commands like the up to vertex, so I don't even have to type in any dimensions here. Again, because all this geometry has already been created for me. We just use those up to vertex tools to make sure that that part cuts the whole way through, or gets extruded the whole way through. What else is great is this is supposed to be a cutout in the part, so I can simply select that shape there, and I can use the Convert to Cut feature now, and use that as a cutaway that cuts the entire way through the model. Now, I also know, Dan, based on your 2D DXF, that the design intent for these holes is actually to fit an M5 fastener. So rather than actually using those to cut down the counter bore for this, what I'm actually going to do is use a combination of your 2D sketches and my SOLIDWORKS tools like the Hole Wizard here. So if you convert a 2D sketch into 3D geometry, you're not restricted to using only those 2D sketches. So you can see using the powerful Hole Wizard feature here inside of SOLIDWORKS, I can actually identify that I want to use a metric pan crosshead screw that's a size M5, and I want to make that a counter bore for that fastener. So very quickly, I can go ahead and position this based on the original positions in your 3D or in your 2D sketches. And then as soon as I accept this command, I very quickly get those counter bore cuts. So you can see, even though we're going to go ahead and reuse a lot of that existing 2D data, we can actually build our own SOLIDWORKS features on top of that. So it's a really, really great way here to create the files that you want. So I'm just going to name this file here clamp. And now once I have this part actually designed, you may be interested in assembling these components together. So I want to show you here how SOLIDWORKS makes assembling components very simple as well. So what I have is actually a larger assembly, and again, I already did some work to this and built this ahead of time, but I want to simply add that 2D part that I just generated to this model. You can see this is actually an underwater sea robot, so it's going to be piloted via remote control, and I really want to use this arm here to be able to look at items underwater and investigate them and clamp on. So the clamp that we just designed, I need to set on top of this piece. What's great with SOLIDWORKS is that we can see the entire assembly built together, but we can also identify different subcomponents or sub-assemblies, as we call them here. So you can see it's a grouping of components that kind of all fit together. So if I simply open this up in its own window, it's going to make it a little easier for me there to insert my new clamp and put that right into place. So once I have the new clamp file there inside of my assembly, I can just simply identify some of these faces that I want to attach together. Simply holding the control key, I can click several of those faces, and it's going to line them up for me. So just like here, I'm going to line up the bolt holes with a concentric mate, or concentric relationship. and then everything fits together perfectly. So you can see, Dan, there it was very quick for me to go ahead and generate those 2D or the 3D files from your 2D data. What I was able to do is, what I was able to do there, I was able to open up a native DXF or DWG file right within the SOLIDWORKS interface. I was able to define my standard views of the part and change those sketch planes very quickly. I was able to use existing data to create the 3D solids, and then I can also use a combination of the existing data and SOLIDWORKS features to make that all possible. So what do you think, Dan? Does that answer your question there?
Yeah, I mean, it certainly does, and my apologies for cutting you off before. I was just amazed. It's a huge relief when I think of it because, you know, having to go back and do a lot of rework to things that I've already put a lot of time into creating, I just think that's really awesome. So thanks for sharing that. I have another question for you, though, Matt. Although that's really great, I'm constantly making changes to my design and having to, in turn, manually update those changes in every single view in my drawing. Would you possibly be able to show us how SOLIDWORKS handles this process? Can it really automatically update my drawings and bills of materials?
Sure, Dan, absolutely. So let me go over into SOLIDWORKS and I'll show you some of those changes. So right here, I'm going to take this part and actually make the 2D drawing from that. So I'm going to use the template that I want to work with, and that's going to automatically define all the title block and the background information that I want. And right from the SOLIDWORKS model, I can actually drag out my front view and very quickly project the right view, the top view, and the isometric view, and any other standard views that you want to work with. So because SOLIDWORKS already has the 3D data, making those 2D drawings is that much easier. Now also, because we already have the dimensions here, I can simply insert all the dimensions that we had from that model over into this drawing and then look at any changes. So what we can actually see here, based on your exact question there, what happens if I make a drawing change or a dimensional change? So if I go over here to the assembly, what I'm actually going to see and notice is this part doesn't quite line up. So I need to make a modification to some of these dimensions. We have powerful measurement tools built into SOLIDWORKS as well. So I know that the total width of this part really should be about 60 millimeters and not the current value of my part. I also need to measure this portion of it, and we can see that makes that 32 millimeters. I'm sorry, we wanted to measure the original. So my current value is 32, and I want to make that 30. So that's simple enough. What I want to do is go back over here into my 3D model and simply take a look at those original sketches. So with the establishment of the original sketches, I can very quickly go in here and add those dimensions in. I'll just make that 60 millimeters, and it's going to go ahead and adjust that to match. Again, I'm going to switch the unit system here to 60 millimeters. We notice that the holes got moved over just a bit, but that's fine. I'm going to go ahead into my hole wizard tool here, and I'm going to simply reposition everything where it should be. So with a few clicks, we're able to easily establish these different changes that we want to make here. Okay, and after we get these all positioned up right where we want them, we're ready to start designing this part. And working with this part. So you also notice that after I made those changes, this cutout needs moved over just a bit, which is fine. So whenever I go over to the 2D drawing, though, we're going to see that all of those changes that I make actually update accordingly. And now whenever I start to add these dimensions into my drawing there, you can see it does call out those new values that I entered in. And again, coming back over here, I'm just going to simply make a change to this original sketch, and I'm just going to center this up on the midline over here. And just by doing that, it's going to automatically update my drawing views. So what I'm able to do is very quickly make a change to the 3D model, and you can see how that automatically propagates around to all those different drawing views. So again, Dan, I hope that I answered your question there about making your design changes and watching your drawing views update automatically. You can see I was able to easily identify the necessary changes in the assembly. I was able to update the drawing views with just a simple few clicks there. And then the main benefit here is I never have to wonder if I make an update to my model, if it's going to affect, or if I made changes to all the necessary drawing views everywhere that that particular model was used. So what do you think there? Do you think that would help you out a little bit?
I think it would help me out very much. And I mean, I can't even tell you how much time it's taken to go back and manually make those changes. So it sounds like it really reduces, the chance for me to, make any errors moving forward, being that a lot of these updates get done automatically. I think that's super cool. I do have more questions though, Matt.
Okay. What do you got, Dan?
So here's what's interesting. So we're finding ourselves having to do frequent reworks before going into production. So our parts specifically don't always fit into our assemblies, and oftentimes we find assemblies can't move the way that we originally intended.
Okay.
Can you show us in some way how you do that in SOLIDWORKS in terms of detecting interferences? Can you even do that?
Sure, Dan. So actually, that's one of the most powerful functions and one of the biggest benefits that SOLIDWORKS has to offer. So whenever I have a file generated in an assembly, simply closing down the drawing here, I can go over into the assembly and actually detect for any types of interferences that I may want to look at. So along with the measuring tools, we have some powerful interference detection tools to take a look at any issues that we may have with the assembly. So I can launch my interference detection tool and calculate the interferences for the entire model. And what's great about this tool is it actually shows you everywhere in the model that we may have problems. Now, I do notice that there's some small interferences in here, and those are actually intended interferences. We have some gaskets in here. As I mentioned, this is going to be an underwater robot, so we want to ensure that none of the water actually gets in and seeps in through the seals. So we have some intended interferences with the gasket. But what I can do is roll up here and find an actual large interference. And with that, I can zoom in on this area, and SOLIDWORKS highlights exactly where that interference is. So I can identify that the hole used inside of that clamp actually is not large enough. So I want to go ahead and make a change to that part and see how that affects our interferences. So let me go ahead over to the clamp again, and I'm going to edit the sketch here for this cut extrude, and I'm just going to simply add or change the dimension. You can see the original value was 12, so all I need to do is make that 12.5, and now I'm going to have a great cut extrude that should reduce or eliminate that particular interference. So going in here now, I'm going to run the interference check one more time, and we can see that that large interference between those files is actually removed and no longer there. So another function that we want to take a look at here in this assembly is the ability to move components around, which you can do very freely inside of SOLIDWORKS. But what you'll notice is you can actually move components through each other, and that's so that we don't have to build it in SOLIDWORKS the way that we would in real life. So we can utilize some of our powerful tools like the Move Component tool with collision detection to actually look at anywhere that there's interferences in the model and have it stop anywhere it does find those interferences. So as I start to drag this model around, you'll notice that as it collides and runs into itself, we're actually going to see that interference and it stops the motion here, so I can't drag it through. If I want to look at the full range of motion, I should expect this handle to push the whole way through. But what I find is it's actually stopped. So I'm just going to investigate what's going on, and it actually looks like somebody designed a little nub on the bottom of this cylinder for some reason. And as we go through the interference check, we can actually see it running into it right there, which isn't what we want. So I want this to be able to extend a little bit farther. So the interference detection tool was able to very quickly identify where the problem area was, and that's going to allow me to open up this part file and get rid of that extrusion that was on there so that we don't have to worry about that problem happening again in the future. So now as I go back to my assembly, I'm going to launch that same Move Component dialog, use my collision detection tools, and now I should be able to get that full range of motion that I'm expecting throughout this assembly. So you can see, Dan, with those tools, it's very simple to identify any potential problem areas with your models and very easily correct those. So I was able to find and compare the intended interferences versus unintended ones, and you can see your design work before it's ever built. So hopefully that should help you before you send drawings out to the shop, get everything manufactured, and then finally find those problems. So what about that, Dan? Does that answer all your questions?
It answers most of them, not all of them. it's good to see that, obviously we can do some validation earlier on in the process to avoid rework costs, right? Because that's something that's important to us. We're always trying to cut costs wherever we can. So I think that that's really helpful. Thanks for showing that. But I do have one last question.
Okay.
And I'm having issues. One thing that's really frustrating for me, I should say, is that it takes hours, sometimes days, for me to create exploded assembly drawings and bills of materials. I was hoping it doesn't take that long in SOLIDWORKS. Please tell me it does not.
Sure. So actually, it doesn't take that long in SOLIDWORKS. And that's another one of the great benefits and one of the powers of using SOLIDWORKS software. So what I can see is I already have most of this assembly built, and I just made a few changes, and I added in my clamp down here, and I want that information to be easily identified. I also want to make an exploded view. So within SOLIDWORKS, it's very quick to make exploded views and reuse those as we see fit. Now what you can see is I already started an exploded view for this assembly, but I'm just going to open up this feature very quickly to show you how easy it actually is to create these exploded views. So the bar assembly down here has not been exploded, so I'm just going to simply select any of these pieces that I want to move around, and then simply dragging the triad that's on the screen, I'm able to move those pieces out of the way. So I can grab these screws and move those down as well as my lower clamp. And I can finally drag this top clamp up out of the way as well. So you can see exploded view creation, very quick, very easy. Just click on a few components and drag those around. One of the other great functions here is we can quickly collapse and explode those exploded views. And we can also look at animations. So if you want this to be more of a step-by-step assembly process, you can absolutely do that as well. So you simply lay out the exploded view so that it looks correct, and then you can animate this, saving it out to an AVI file so that someone without SOLIDWORKS can actually look at this animation and see how it should be exploded. So some pretty powerful exploded view functionality there inside of SOLIDWORKS. But let's really get into your main question was making your bill of materials. So I want to take this assembly and I want to make a drawing from this with your bill of materials. So I'm going to simply choose the template I want to work with, and you'll notice since I have an exploded view already, it automatically gives me the option to bring in that isometric exploded view. So I can very easily change this display style so we can see all the colors of this model. And then what I want to do is quickly identify a bill of materials for this assembly. So I simply set up the settings that I want for that bill of material, and then very quickly it's going to automatically the bill of materials that you can place wherever you'd like to place it in your drawing. Also, along with that, we can actually balloon this drawing automatically. So if I select my auto balloon tool, it's going to go through the bill of materials and it's going to identify one of each elements inside of my assembly. We certainly have a lot of control over these balloons and how they look. I can make sure that all the balloons maybe fit to the top of that model instead of at the bottom. We can order those sequentially around the view. So the items numbers start with 1, 2, 3, 4, 5, and go on from there. We can also change those as far as what the information inside of the balloons call out. And you can see with my magnetic lines inside of SOLIDWORKS, I can very easily position all my views along these lines. And then it's a very simple drag and drop operation to reach components so that the view looks very nice and neat. So in summary there, again, I was able to very quickly generate the exploded view that you asked for. Outside of that, it was an instant bill of material process. Simply choose the template I want to work with, click the Go button, and we have that bill of materials calculating all the item numbers, part numbers, quantities of each of those items. And then we also use the automatic ballooning just to save us a bit of time. And Dan, as I mentioned earlier, with our drawing changes, if I needed to make any changes to that assembly and add or remove components, your bill of materials actually get updated automatically throughout that process. So you don't ever have to worry, again, about your drawing being out of date from the actual 3D model.
So if I sub in a part that isn't in my assembly, that will automatically update in my bill of material.
Exactly. You don't have to remove a line item and then re-enter a new line item for the new component. It'll automatically go ahead and make that change for you.
Wow. Wow, that's really cool, Matt.
So what do you think, Dan? Does that answer all your questions now?
Yeah, I mean, I think it certainly does, and really well too. So it sounds like in terms, just to kind of summarize, I am able to reuse my 2D data when moving into 3D. Also, automatically updating all of my drawing views, detecting and finding those unintended interferences before our drawings get to the shop, and lastly, creating those exploded assembly drawings and bombs and build materials, which is huge because our customers and clients have a need for some of this visualization and animation features. So, that's the sort of stuff that they like to see. So it's great to see that that's a possibility within SOLIDWORks.
Okay, great. I'm glad I was able to answer all those questions that you had for me.
Yeah, and I guess, just to kind of transition at this point, obviously to kind of hear from what our customers are saying about the switch, right? So just as an example, what we're showing you is important to our customers. So we did get some insight from them. More specifically, on the updates to all drawing views feature, Todd Becker is a senior designer with Reading Truck Body, was nice enough to give some insight just on their experience. And I know that you can see these, but in the interest of reiterating, just to read them off, Todd mentions, long gone are the days of doing a save as and updating different views on a 2D drawing and hoping that something wasn't missed. Keyword obviously being hoping, right? So obviously speaks to the idea of reducing those errors that are associated with doing a lot of this stuff manually, right? So obviously the automatic updates reduces the chance of making those specific errors. The automatic update is a great feature within SOLIDWORKS, so we appreciate Todd sharing some background there. In reference to interference detection, one of our other customers had mentioned that one of the big things that they like within SOLIDWORKS 3D CAD are spatial relationships, obviously being able to detect interferences and design parts that fit up perfectly. So again, understanding what those unintended interferences are earlier on in the design process to avoid costly reworks. And as far as animation functionality and visualization, one of our other customers has mentioned that one of the biggest things for them is visualization, one of the biggest advantages over 2D CAD. So not only for them during design, but as I even alluded to before, also for our customers when we present a concept. It's something really important that clients and customers like to see, and SOLIDWORKS 3D CAD really does give you that visualization functionality. So we just wanted to kind of extend a big thanks to some of our customers for providing some great insight on their experience and that potential transition. Really helpful, and it's good for companies or individuals that are thinking about making the transition from 2D to 3D. We hope you guys found this valuable. I guess, we weren't really able to take any questions earlier on or periodically throughout the presentation, so we wanted to designate a minute or two. We know we're at half after 2, but if there are any questions, certainly feel free to type them into the question box, and Matt and myself can certainly answer those. In the event there aren't any at this point, and maybe they come up periodically throughout the week or at any other time, it looks like we have a question coming in. Let's see. Otto, if you can type your question into the chat box there, and then we can get that answered. And as you're doing that, if there are any other questions, obviously, you can give us a call or shoot us an email, and we can certainly field and get those questions answered as you have them, most definitely too. So again, we appreciate everybody setting aside some time. Otto, are you able to get that question into the question area down there? I'm not seeing it come through. Let me see here. Yep, it doesn't look like that's coming through. We can certainly table that question and certainly get back to it on a one-to-one basis. Otto, no problem at all. But again, thank you guys very much. Again, this is just kind of a quick summary of what we covered. So, as noted earlier, we can reuse our existing 2D CAD data into 3D. And we are able to have those automatic updates to all our drawing views, emphasis on the all, of course, are able to find those interferences before drawings get to the shop, and create those exploded assembly drawings and bills of materials in minutes. So again, Matt, thanks for taking some time to demonstrate that. It was really helpful. I hope everyone that joined us this afternoon found it helpful as well. My contact info is below here, email address and phone number. Again, if you guys have any questions on anything that we saw today, please feel free to reach out to me, dpetito@designpoint.com. Obviously, Matt is our senior application engineer, so certainly you can bounce questions off of Matt as well. But again, thank you for taking some time this afternoon to join us, and enjoy the rest of your afternoon, everyone. Thanks so much.